So let's start out with the concept of light. First off, please understand that the concept of light, when you think about and refer to light, what you were really referring to is the concept of visible light. And visible light is a very small portion of the electromagnetic spectrum. Open up your text at page 521. You'll see this table. And this table is a table of the electromagnetic spectrum. Now, the electromagnetic spectrum contains radio waves, microwaves, infrared rays, visible light, ultraviolet light, X-rays, and gamma rays. And it gives all of the various ranges for them. And the important thing to realize here is that light is just oscillations of electric fields and magnetic fields. So visible light, the electromagnetic spectrum, all of these things are alternating electric fields and magnetic fields. It turns out that a changing electric field creates a changing magnetic field, which creates a changing electric field, which creates a changing magnetic field, which creates a changing electric field, which creates a changing magnetic field, and so on and so forth. Electromagnetic radiation is the only form of a wave that we know of that is a self-propagating wave. It does not need a medium to pass through. That's why it can pass through the vacuum of space, because we have an oscillating electric field which creates a changing magnetic field, and so on and so forth. This is a much better chart of the electromagnetic spectrum. This is not the one in your textbook, but this is the one that I'm going to refer to. And the reason I like this one is not only because it gives various frequencies of things that you work with on an everyday basis, like X-rays, but it gives a good visual representation of how small the visible light range is. That portion right there, about the width of my finger, is the visible portion of the electromagnetic spectrum. You can see we have the frequency and the wavelength of all of these various types of electromagnetic waves. Now, visible wavelengths go from 700 to 400 nanometers. How many sig figs, class, on 700? 400? One sig fig. Why? Why would there only be one sig fig? Visible light. Visible to whom?
People.
People. Which people?
Us.
Do all people see the same wavelengths? Not necessarily. Okay. So it is a visible light spectrum, and we all see approximately the same wavelengths, but not exactly the same wavelengths. In addition to that, the concept of there being a hard, if it's 399.99 nanometers, that makes it ultraviolet. That's not actually correct. Okay? There are ranges, and the effects of ultraviolet light are actually, you can see slightly in the visible range, and so on and so forth. So they're not like hard and fast rules that we have at this particular wavelength that has to be this type of wave. It's that the characteristics of the different waves, X-ray radiation we've used, generally is in this wavelength range. So those are the different electromagnetic waves. Now, we have an equation that talks about the speed of a wave back from chapter 12. And that is the speed of a wave is equal to the frequency of the wave times the wavelength, right? So speed of a wave, we derived it before. Now, there is something called the speed of light. I don't actually like this term because it implies that light is the only thing that travels at this speed. It is true that this is the speed of light. It would be more correct to call this the speed of electromagnetic waves. And that speed is, the symbol we use is a c, and it's 3.00 times 10 to the 8th meters per second. Or if you prefer really fast, 186,000 miles per second. 186,000 miles per second. And this is the speed of electromagnetic waves in a vacuum. It's also pretty darn close to the speed in air, so we'll consider them to be the same. It's not quite, but it is close enough for the purposes of this class. So this is the speed of electromagnetic radiation, or electromagnetic waves, in a vacuum or in air.